Welcome back. Today we're going to continue our discussion of experimental methods by talking about threats to validity that we should keep in mind. So just as a quick review, we last week talked about how experiments are attempting to establish causation, and they do this through three ways. The first is to address covariance through manipulating variables and using comparison groups so that they know where change happens. They also try to address internal validity, controlling for confounds by using these control variables, and then other ways of finding these design confounds that we can deal with. And then finally, we want to establish this temporal precedence by making sure that our groups are similar at the beginning through this random assignment. And good experiments are going to control for as many confounds as possible, and we do this with different types of designs, such as a between subjects design, where each individual, each participant, is going through exactly one condition, or a within subjects design, where the participants go through multiple conditions and experience multiple levels of the independent variable. We also have a pre-test, post-test, which determines when the dependent variable is going to be measured, whether it's before or after only. And these different designs and combinations of these designs have different benefits and different drawbacks. And so part of being a researcher is looking at the different ways we can design a study and deciding what is best for our measurement, what is best to answer our question. And as we are doing this, we always want to keep in mind threats to validity, which is what we're going to be talking about today. As we go into today's lecture, I want to remind you about our example from last week, which is the question of, does writing about a traumatic experience reduce negative emotions associated with that experience? The way we addressed this was we had two groups or two levels of our independent variable. One was thinking about the experience and one was writing about the experience. And then we had our outcome variable, the dependent variable of well-being, to see how well somebody was doing depending on whether they had thought about or written about the experience. You may recall that we talked about different ways we could design it. Here are the layouts of it. So on the left, we have our between groups design, where we have a sample, we randomly assign them into either condition, and then afterwards we're going to measure their well-being. Or we could have our within groups design on the right, which is we have a sample, they go through one condition, all of them go through one condition of thinking about the experience, then we measure their well-being, and then afterwards we go through the second condition. So again, we're seeing them in multiple levels of the IV here. But I want to take a minute to revise this example. Let's say we have the same question. We're trying to understand whether expressive writing affects well-being after a trauma. We're going to take a different approach. In this example, we have a therapist who sees 30 patients a week and decides that they want to try expressive writing. They go to their patients and they give them a well-being score, so this pre-test. We then introduce the expressive writing, and the patients engage in this expressive writing for about 6 months, let's say. And then at the end, the therapist reevaluates the well-being, so takes a post-test score. So let's take a minute to think about what's happening here. We're introducing the variable of expressive writing, and we're seeing well-being. So this might, at first, seem like an okay experiment. However, it has one major problem. The issue is that it's known as a one-group pre-test, post-test design, which is actually a really bad experiment. So you'll see that in this process, you have the sample, and they are measured once on well-being. That completed the dependent variable. Then they went through a treatment, which is the writing, and then we measured them again. But the issue is that we're only putting them again through one level of our independent variable. There's nothing to compare against. There's no control group to know, would they have done better if they were in the treatment group? Would they have, or in the thinking about it group? Would they have done worse? Maybe. Maybe writing is actually bad for it, and we're seeing a little bit of change, but it could have been better. Maybe people just had better well-being over the course of the 6 months, regardless of whether they were writing. We don't know that writing itself did anything. But instead, the therapist is going through their 6 months thinking, oh, I did expressive writing, and now my subjects have better well-being, so I must have done something right. And this leads us into what's called a pseudo-experiment, where a researcher is testing, quote unquote, a claim about a variable by doing something, exposing to one level of a variable, and then saying, hey, look, that variable had an effect. But we don't actually know. There's a lot of reasons why the dependent variable might have changed between the first time point and the second time point that might have had nothing to do with our treatment. Well-being may have changed for reasons that had nothing to do with writing and that specific intervention. And so these pseudo experiments, people may feel a temptation to validate what they think is happening. They have an expectation. They think, oh, yes, this independent variable was the effect, but it's not true. And so these are major threats to internal validity. And we are going to talk about three different ways that we see this threat, three different ways we may have other things that are affecting the dependent variable besides our experimental treatment. And those are going to be because people are different, because people change, and because studying people changes people. The first threat to validity in any kind of experimental method we're talking about is going to be that people are different. There's a lot of individual differences between our subjects that we have to take into account. People have a lot of variability between them, and the kind of people we have in our population or the kind of people who participate in our study might affect our ability to interpret our data. For instance, there might be selection bias. This is when we sample people that don't actually represent the regular population. We already briefly touched on this with the idea of weird samples, which are those Western educated, industrialized, rich, and democratic, which has been the major sample that psychologists have used over the past many decades. And coming up with understandings of psychological phenomenon just from that sample doesn't represent necessarily the entire population. We also have different cultures that are going to respond to our variables in unique ways, and without comparing against other cultures or comparing against other samples that might be represented, we don't know whether we're representing. We don't know whether the people in our sample are actually the population. I always think about this with Cosmopolitan magazines used to publish a lot of surveys of what do people think and what are these mentalities around the signaling to other mating rituals of humans. And they would always get some interesting data, but that was because the people they were sampling were Cosmo readers, or not even just Cosmo readers, people who were willing to go out of their way to respond to a Cosmopolitan poll. We think about this also when it comes to YouTube reviews or Amazon reviews, that the comments that are put in there are usually from the extremes, not necessarily from the people, just everybody in the population, the people who have the kind of more middle ground appreciation for a product or a video. So the selection that's coming in is not necessarily representative of the entire population. Another way that people are different is that there's always going to be some kind of non-response bias. This is that the people who don't want to participate or don't want to continue through with a study might be different than the people who stay in the study. So for instance, we have found that volunteers or people who are high in conscientiousness generally follow through on an entire study, whereas people who are less conscientious or have other things that are pulling their attention might not be as might not follow through on a study. So in the end, the data that we get really is just conscientious individuals. And conscientious individuals, these volunteers, are going to look a lot different than our general sample. So because we have these individual differences that might affect our participation or an individual's participation, that needs to be taken into account when we're interpreting our data. That might affect the dependent variable other than our independent variable. So these individual differences with selection bias and non-response bias can affect both the internal and external validity. The internal validity is that there's a third variable problem that might be that conscientiousness or the culture that they're from. And then the external validity is always how representative of the population are there. Can we take what we found in our sample and apply it to the bigger world and apply it to other people and say that we found something interesting about humanity or about our specific population? The second big picture threat to validity is that people change. That is, they might have changed regardless of the treatment. We could just leave them alone and their scores on the dependent variable would shift. So we can't just attribute that to the treatment that we gave them. Just because well-being changed over the course of the 6 months that the therapist was working on it doesn't mean it had anything to do with the expressive writing that was given. And one way this happens is through maturation, that people just naturally change. They just shift. Maybe they get more mentally sound, or maybe they get more physically adept, like a 12-week study of young dancers, these tiny dancers, get it? Well, it might be that they're being trained to dance better, or there's some intervention in the dance studio that's supposed to excite them. Maybe that's having an effect, or maybe it's just that these little kids are getting more physically adept generally. They're running better, they're jumping better. All of that is happening naturally, and they would have been better dancers at the end of 12 weeks, whether or not we had done anything. We don't know unless we have a comparison group to work with. It also might be that there are external events that might affect how people perform and how people change, and this is known as history. For instance, in New York City in 1999 and 2000, maybe there was a little bit of emergency preparedness, but then something major happened in New York City in around 9/11, and that's going to, of course, affect people's mentality, and suddenly an entire group of individuals might act a lot different. So if we sample them before and after a major external change, that certainly, we're going to see some effect there that might have nothing to do with any other variable, any other independent variable we had in our study. There also might be regression to the mean. This is when you measure somebody at one time point and you find that they are performing really well or really poorly, and then when you measure them again later, they are more normalized. This is usually because of a fluke, that it just happens that we have found somebody who's really high on a variable, but it's not because they're actually high, it's just because of something that some noise that's happening in the data at that point that results in them doing really well. This is kind of exemplified by the Sports Illustrated curse, this idea that when an athlete is doing really, really well, something, the stars are aligning, and they are performing expertly, Sports Illustrated will say, look at this person, they're just amazing, they've done so well, they're the best athlete ever, and then the next year, the athlete won't do as well. And that's not because the athlete's gotten worse necessarily. It's just because the stars again were aligned. Everything was in place for them to do so expertly that we honed in on them. But they're still just a human being, and they're still going to kind of regress to the average, regress to the mean by natural causes. So extreme measurements that we find that we kind of cherry pick and say, oh, there's something really interesting here. Maybe it's interesting just because, again, things are aligned in a perfect way. Something about the way we're measuring or what we're measuring at that exact time point, or the person slept expertly that night before, or recently studied something that really helps them to answer our dependent variable. All of these extremes could happen in that one time, but then if we ever assess the individual again, we would find that maybe they're more normal. Maybe they had a normal night's sleep, or they had forgotten some things about what we were assessing. So there is going to be some natural change we're going to see. It doesn't mean people are worse later or people are better later. It just means people are normal. The third major category of threats to validity is that studying people changes people. This could happen through the mere measurement effect, which is that participants change their behavior when they're asked to think about their future behavior. For instance, we've seen studies where people are asked about buying cars, and if we just left them alone, maybe they wouldn't care about a car at all. But as soon as you ask them about whether they're going to buy a car, they start to think, you know what, I hadn't thought about it. Yeah, I could buy a car. Maybe I'd like this kind. But they're kind of primed to think about something that they wouldn't have naturally been thinking about before. Simply asking someone, how's your well-being, is going to make them start to reflect on their well-being and think about it more than they would have, and maybe suddenly put in a place where they have to think about their well-being, may bring up issues. They think, oh, well, actually, I hadn't thought about it, but things aren't going as well as I wanted to. But again, they would have been, when left alone, very different than how they were when we asked them about things. I saw this a lot in my own research, where people are going about their day, and then I suddenly ask them about all of their anxieties about the world and about their college stress, and sometimes they say, oh, well, that was actually kind of challenging because I wasn't anxious until you started asking me about how anxious I was. And so we had to be really careful with that, about priming people to think about their anxiety and how that might affect our ability to interpret and affect the validity of our studies. There's also a testing effect. This is the tendency that people perform better when you test them again. They have gotten used to the style of questions, and maybe they've practiced a little bit or done a lot of rumination on whatever you're asking them about. If you ask them about well-being at one point, they're going to start thinking more about their well-being and maybe doing things that might change their well-being. Or if we ask them about their IQ, they're going to get we're going to get better at answering those questions in the format of those IQ tests. You might have seen this if you ever had to retake a test in your courses, that suddenly the second exam you do a little bit better on, simply because you understand your professor a little bit better and how they ask questions. So simply testing someone at multiple time points, this pre-test, post-test, is going to affect things. And if we don't have a control variable or some way of assessing whether or not they just got better through the test retest, we don't know whether that's actually what's affecting our dependent variable. Another issue with how studying people changes people is attrition, which is the failure of some participants to complete the study. You'll also see this known as mortality, this death of a participant, which is a little morbid, but the idea that you're not able to follow up with them because they've stopped your study. And this can happen in two ways. The first is a homogeneous attrition across conditions. If you have multiple levels of your independent variable, so let's say we have a red group and a blue group, not necessarily red people or blue people, but just the red condition and the blue condition. They're going through some experiment that changes their color to red and changes blue, whatever, I don't know. But we have two groups here. Homogeneous is when we have the same proportion of individuals falling out of either condition. So in this case, 50% of participants are falling out of both conditions. The other alternative is what's known as a heterogeneous, which is where we have different attrition across the conditions. So again, we have the same hypothetical sample population of a condition for red and a condition for blue, and we'll see that a different proportion are falling out. The homogeneous attrition is not necessarily an issue. That we're going to have the idea is that the same kinds of people are falling out of both. Now, we still have the issue of people are different, so what people are falling out might affect our validity, that maybe all the conscientious people are staying in our study, but the non-conscientious are falling out. The issue is that we have more representation in one condition than the other, so it might be that something is happening in a condition that is scaring people away. Maybe the red condition isn't easier to fulfill, whereas the blue condition is really challenging. And so we have less data about the blue, and the kinds of people who really stick it through might be unique versus the red. When we have different fallout, not only are we including this people are different, but also that something about the way we are studying people is causing people to drop out. A classic example of this is this expressive writing. You take a sample and you say, I want them to expressively write. And then we find out that the kinds of people who stick through that study are people who found a lot of benefit from it, who are thinking, oh, this is really great. I'm thinking about my life and I'm feeling good. And so, yes, I want to continue with this study. But we've also found that there's a kind of backlash to some individuals who may find that the expressive writing actually really hurts. So this is usually with people who are experiencing depression, that trying to write about their experiences actually reinforces these negative feelings. And so people who are naturally depressed might find that going through an expressive writing study makes their life feel worse, and they stop doing the study. And in that case, we would find out that, oh, our final sample, everybody who did the writing, they all felt better. But it's only because the people who were made worse by the writing, we didn't get their data. They had a higher attrition than the people who felt better about our study. So the conclusion we came from about, oh, people are getting, the expressive writing is helping a lot, isn't actually valid, because we have different attritions across different conditions, different people. Another way that studying people changes people is through reaction bias. This is when people behave differently when they realize they're being studied. We talked about this before earlier in the semester about when people are being observed, they might change and they might get in more fights or they might get in less fights. They suddenly put on a show when they realize they're being observed. The same thing can happen in an experiment. When people figure out that they're being studied and they're being analyzed, they might change their behavior. Now, I want to make sure that this is different from the idea of we're priming people to think about buying cars or being anxious or how much their well-being is, and suddenly they, oh, I hadn't been thinking about this before, but now I'm going to think about it. That's just the internal kind of state shifts. Whereas a reaction bias is simply the fact that I'm being studied. Now I'm going to act different. I'm going to behave differently. And this can go in a number of different directions. One is through expectancies where the individual is attempting to behave consistent with the hypotheses. They're trying to match whatever the researcher is trying to figure out. This usually comes about through demand characteristics, which is the beliefs the participant has about how they should behave. And this can be different across participants. Not every participant is going to have the same idea of how they should behave. Maybe they think they're supposed to really care about cars, or they think they're supposed to have really high or low well-being, depending on the context. But whatever it is, they are trying to follow through on those demand characteristics, trying to match them so that they are consistent with the hypotheses. They're trying to be nice participants and help the researcher out, because they know the researcher's doing this for a purpose. They've kind of internalized, yes, I want the researcher to find out something interesting. We've shown this pretty significantly through the presence of weapons associated with aggressiveness. So you bring a participant into the lab, and in a normal situation, you might measure their aggressiveness of how do they knock over pens, or do they open and shut doors on other people, or you might remember the Tabasco sauce example of how much Tabasco do they put in the person's soup. So we can measure aggressiveness, but if they come into the lab and then they suddenly see a weapon on the table, they think, well, that's not something I normally see. Why is there a gun on the table? Why is there a weapon around me? And in their mind, that weapon is going to cue thoughts about what the researchers study. Well, okay, there's a gun on the... Well, guns are associated in our culture with aggressiveness. And so, oh, the researcher might be trying to study aggressiveness. They want me to be aggressive. They're trying to make me aggressive by putting this here. Oh, okay, I'll be aggressive. So I'm going to put more Tabasco sauce, and I'm going to knock over more pencils and slam doors, because I know that that's what the researcher is trying to study. That presence of a weapon is a really strong cue as to what the demand characteristics might be. Now, again, they could interpret it of, am I supposed to be more aggressive? Am I supposed to be less? I don't really know. The individual's demand characteristics in their head might shift, but whatever it is, they're trying to behave consistent with the hypothesis. This is what's called a weapons effect, or the expectancy of a weapons effect. Of course, you might have some participants who come into the lab, see that gun, and think, oh, this is about aggressiveness. Well, I'm going to be as nice as possible because I'm going to go through reactance. This is the attempt to disconfirm the hypotheses. They say, I know what the participant's studying, but I'm not going to go along. I'm not going to be a sheep with this. I'm going to stick it to the man, and I'm going to do the opposite. It isn't what the person would normally do. Maybe that gun would make them more aggressive, but because they are seeing it and they want to stick it to the man, they're going to act differently. The key here is that neither expectancies nor reactions is what the participant would do normally. Because they are being studied, because they've figured out what the study might be about, or they have an idea of what the study might be about, they're going to act different than they would normally. So you're not really studying how people act around weapons. You're studying how they act when they're thinking about how weapons might be aggressive and how they're in a study about aggressiveness. They're changing their behavior based on the study. Another way that we might see this reaction bias is through apprehension. This is a concern about being judged, and so the behavior changes simply because people feel they're being watched at all. This has classically been shown in the Hawthorne effect. This was a big factory in Hawthorne, Massachusetts, I believe, and they wanted to know, how do we increase productivity at this Hawthorne plant? And so they tried a number of different things. They put in brighter light bulbs, and they found, oh, hey, people are working better. Well, let's try something else. They dimmed the light bulbs, and people were still doing well, the factory workers were still having higher production. And so they tried putting them on different schedules, giving them longer lunch breaks, making sure they had uh, colleagues to band together to talk about their work productivity. And they tried many, many interventions. And guess what? All of them worked. You could give them longer lunch breaks, give them shorter lunch breaks, give them brighter lights, dimmer lights. No matter what they did, things worked. But then the researchers would say, oh, look, people are being productive. And then they'd leave, and then production would go down. Okay, so they'd come back and they'd try something else, and production would go up, and then they'd leave, and production would go down. And then they'd come back, and the production would go up with some other intervention. They just found, we don't understand. We've tried all of these interventions. All of them seem to be working, but then things fall apart. And after a while, they realized it wasn't that they had light bulbs or work groups or longer lunches. It was that they were being studied. Simply being observed, the factory workers were saying, oh, I don't want to fall down on the job. Look, all these researchers are here, and my manager's looking over my shoulder to measure how productive I am. Well, guess what? I'm going to be productive right now. My morale is going to be higher. My productivity is going to be higher simply because I'm being watched, and I don't want to look like a lazy worker. But as soon as no eyes are on me, well, then I can go back to business as usual. So simply studying the individuals, studying these factory workers led to this higher productivity, led to changes in the dependent variable. Nothing to do with the actual interventions, everything to do with the fact that people were being studied and they were reacting to the fact that they were being studied. This is going to happen more with socially desirable or individuals with a high social desirability where they want to look good, they want to follow whatever is being assumed of them. Whereas people who just don't really care about what other people think, they don't have a high social desirability, we're not going to see as much apprehension. We probably also won't see as much reactance or expectancies in those individuals. And so that might be something that we want to measure in our population as this social desirability. How much are you changing your behavior based on what you think I want, to measure that reaction bias or to account for that reaction bias? Another way that studying people changes people is through this placebo effect, which I'm sure you've heard of. This is when participants who are in a condition that doesn't actually have any experimental manipulation, there's just a control group, there's a sugar pill, it's not really supposed to do anything, but then you do see changes in their dependent variable, their outcome, simply because the individual is expecting that they're in an experimental condition. And there's a lot of theory about why this placebo effect happens. It is a real phenomenon where people will see active changes in the dependent variable even though there's no intervention. And this might come from a number of different sources, maybe a misrepresentation of the experience to the researcher, maybe the participant is trying to find things that are different in their experience, even though there actually isn't anything new. There might be different expectations of change or simultaneous changes in other behaviors that might change the fact that they are maybe going through other health behaviors when they think they're taking a medication, might actually have positive effects, or at least changes on the dependent variable. So there's a lot of different reasons why this might happen, but the key here is that nothing should happen, but because we're studying people and because we're putting them in a condition where they think they're being studied and they think they're supposed to have an effect, they might manifest those effects. So it's not really your intervention that's doing anything or your lack of intervention that's doing anything, just the person's mindset that is doing something. So how do we account for this? Well, we want to make sure we have a control group where they're not even being given a sugar pill. They're just neutral state. Nothing has changed. And we can compare the placebo group against that as well as the treatment group against that. We can also assess how much the individual is expecting there to be an effect. So how much do they think the medication or the intervention should affect them? And if they have a high level of, oh, I really think I should feel better after a week, and then we find that, hey, they're showing signs that they feel better after a week, well, that's because that's how they are expecting to change. It's not really what's happening. We can also use a blind experiment where participants don't know which condition they're in. Sometimes this can help. And in fact, most times we do any kind of research, we're going to do a blind experiment where participants don't know the condition they're in, so that we don't have as much reaction. They don't know that they're supposed to be more aggressive or they're supposed to have better well-being. This can somewhat account for this placebo effect. Of course, all of the weight shouldn't just be on the individual participant when it comes to studying people changes people. As we talked about in our discussion of observation and issues in observation, there could be observer bias as well. This is when the researcher themselves has expectations about the outcome. They have their own hypotheses. And so how they observe and how they measure the dependent variable might change. For instance, they might treat participants differently according to their hypotheses. If they know that people are in a certain condition, that they're expecting some outcome, that could affect how they treat those participants. Maybe they act in ways that upset them more so that they can get more aggression, or they watch for more friendly behaviors in couples who are expected to get along. We found this very objectively in the studies of rats doing maze, where if you tell the researcher that some rats are really good at the maze, they're maze bright, and some rats are really not good at the maze, we'll find that that matches, that the ones who are thought to be better at maze will actually, on the dependent variable, come out as better at the maze. But it's not actually that they're better, it's that they're being slightly measured different, or they're being treated different. The maze bright rats are the researchers are a lot more friendly to them, and are cheering them on, and are maybe, clicking a little bit later on the start line and clicking a little bit sooner on the finish line than the maze dull, who they might just kind of throw in the maze and let go and say, oh, well, you're not going to do it well anyway, so I don't really care about you. So the observer might treat the rats different and measure the dependent variable different depending on their mindset. There's also the famous example of clever Hans you may have heard of. This was a horse who ostensibly could do math. So people would come to the horse and ask him, what's 1 plus 2? And the horse would go bump, bump, bump with its hoof, count out 3, and everybody go, oh my gosh, 3. And what's 5 minus 2? And the horse again would go bump, 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 and that would be 3, and everybody would get really excited. And researchers from all over were coming and figuring out, why does this horses shouldn't do math, what's special about this horse? And they did a number of studies where they had the handler there right behind watching the horse, and the handler was trying to explain the history of the horse and how the horse was so smart, and how the handler had randomly found that the horse could do it, and people were amazed. And then at one point they did the study, but the handler couldn't show up for the study, or they were in a different room, and suddenly Clever Hans just wasn't doing math anymore. And what's going on? Bring the handler back in. And the handler was there, and suddenly Clever Hans was good at it. And they're like, wait, hold on. What's going on with this handler here? Let's take the handler out of the room again. And Hans wasn't good at it. And then they brought the handler back, and Hans was good at it. And they kept switching, and they realized, something's going on with the handler. And they realized it was that when they asked the horse a question, the horse would start stamping and would be looking at the handler's face to see when the handler was going, keep going, had eyes to say, I'm still apprehensive, I'm still waiting. And the horse could read the handler's body language of keep going. And then as soon as he got to that 3 hoof stamp, the handler would put a big smile on his face and think, oh, that's great. And the horse would stop stamping, thinking, oh, I'm done, I don't need to stamp anymore. And then everybody would cheer. And that's just operant conditioning there, just watching the operator of the handler. It wasn't that Hans was clever, it was instead the observer, the excited manager who didn't even realize what he was doing. The handler didn't even know that he was giving these facial expressions, but the handler's expectations and as the observer watching Hans was affecting Hans's ability to do math. And so what we have learned from this is observers probably they introduce bias without even realizing it. Maybe we should make sure that the observers can't affect the study themselves. And the only way to correct for this is through double-blind experiments. This is when the experimenter doesn't know which condition the individual is in. They don't know if it's a maze bright or a maze dull rat. They don't know how many hoof stamps Clever Hans should do. They don't know whether the couple that they're observing has just been given the get along with each other experimental treatment or the fight with each other experimental treatment. They just know they're supposed to watch. And we want to be very careful that the experimenter is never given any clues so that they are going through some kind of reactance or expectancies. We want to make sure that the researcher is always blind to it. And of course, as I said in the placebo slide, we want to make sure the participant is blind as well so that they can have less reactance themselves. So we had a lot of threats to validity, a lot on that back end, but just as a review, people are different. So it could be through selection bias, just the kind of people who join our study, as well as the kind of people who decide that they're not interested in responding to our study. We also have that people change over time, and this could be through natural maturation, just getting to be better dancers. It could be through big events happening that change an individual that have nothing to do with our independent variable. And it could be that there was something unique about the first time we assess somebody that is no longer in play the second time. So it appears that the individual is regressing to the mean simply because at the beginning they were a significantly unique measurement, again, because maybe they slept well or they'd heard about something before, and they're just, everybody's kind of getting more to the average at the end. Nothing to do with the IV, just the fact that people are normal. We also know that studying people changes people through mere measurement, this priming individuals, or there could be the testing effects where they're getting better at something simply through repeated exposure. Attrition, where maybe something about our condition is changing whether or not people want to be non-responsive. And then we have our different forms of reaction bias through the expectancies and maybe the observer bias as well. So these are major issues that we want to be thinking about every time we're designing an experimental method. We should also always be sure that we are measuring what we think we are measuring. This is something we talked about before with creating scales. We want to make sure that we have some construct validity, that we aren't coming to conclusions at the end that have nothing to do with our study because we're not measuring what we think we are measuring. Therefore, we want to make sure we're checking our construct validity. One way we can do this is through a pilot study. This is when we do kind of a mini study before the actual study. It's like a small subset just to check whether we're measuring what we think we're measuring, to see, does our hypothesis pan out at all? Are people responding to our interventions in ways that we think make sense? For instance, in a study trying to assess the attractiveness of a picture, we might do a pilot study before and ask a subset, a very small sample, just, hey, we're about to use this picture. How attractive is this photo? And the people might on average say, oh, it's on a 1 to 7 scale, it's a 6.1, with 7 being very, so pretty attractive. And then we show another picture and we find that this one has lower attractive at the 2.8. And hopefully, that's what we wanted. We wanted to have a more attractive, less attractive photo for our study. And we can now know that, yes, we do in fact. Because we could have found a different result. Maybe people actually evaluate both of them similarly. And then if we had just done our big study and we thought that our two pictures were different in attractiveness, but it turns out they weren't, well, that's not going to help us. Now, pilot studies are great if you can do them, if you have time. Sometimes we can't, so we need to do instead a manipulation check, which is kind of an after the fact check to say, well, did people think that our manipulation, did people see one photo as more attractive than the other? So we would ask people at the end, how attractive was the photo you saw? And they would tell us, oh yes, photo A was a 6.1 on average and photo B was 2.8. So we can check after the fact and say, all right, yes, our manipulation worked. If we don't do a pilot study or a manipulation check, we might never know whether our photos were more or less attractive. We are thinking it. As the researcher, we think that we developed a good study, but we don't actually know unless we measure it, unless we check it. Of course, after all of our talk about these threats to validity and interpretation, we also as researchers need to come to the terms that sometimes our experiment just doesn't work. This is what's called a null effect, where the variability in the independent variable was not related to the variability in the dependent variable. You might recognize this word null, which means nothing, nada, zilch. So the null hypothesis is a hypothesis that there will be a null effect. It's thinking that there is no relationship between these variables in the real world, and the null effect is that, yes, indeed, there is no relationship between the IV and the DV in the real world. And there's a number of reasons we might find a null effect, even though we hypothesize, we have a research hypothesis that there is not a null effect, that there's actually a relationship. So why can we find this? Well, maybe our hypothesis or theory was wrong. We did a lot of research. We thought that the IV and DV were related to each other, and it turns out they're not. Now, I want to be careful here, though, because sometimes you might actually hypothesize a null effect. So you might be trying to show that these two variables are not related, and I want to prove, or sorry, show that they are not related to each other. So then that's fine, in which case you're looking for a null effect, in which case you kind of have to flip this, and let's say you're hypothesizing a null effect, and then you do find that there's an effect, well, you're going through these same issues. So again, if you find something contrary to what you believe, what you think is going to happen, it might be because your hypothesis or theory was wrong. It could also be because your manipulation was too weak. The way you were constructing your independent variable just wasn't strong enough to have an effect on the dependent variable. There might be an effect if you were to go more extreme. So maybe you're studying couples and trying to see how they fight with each other. Maybe you didn't prime them with an angry topic too much. Maybe you just kind of lightly kind of push them to argue with each other, and you need to push them a little bit harder to see how they act different. It might also be that your measure, that dependent variable, wasn't sensitive enough in the same way. And there's a couple of ways that this might happen. It could be through a ceiling effect or a floor effect. So a ceiling effect is when the scores already start off too high to the top of the scale. For instance, you may be a researcher who is trying to study IQ, but you're accidentally not really thinking about it using already highly gifted students. So most of the students are going to score near the top maximum possible score. And so any intervention you have might shift one or a couple of students a little bit higher, but it's going to be really difficult to detect the meaningful differences in IQ scores because everybody's kind of already at the top of the scale. If you're doing maybe a reaction time test similarly, where it's really easy and people are able to react really fast to it, well, you're not going to see that some kind of ingesting caffeine or doing some kind of training activity before is really going to help them because everybody's just going to do well at the experiment. So that measurement, the way you're assessing your outcome, is already kind of too high. The opposite is a floor effect. This is when you have things, your dependent variable is already too far at the bottom, and so there's no room for that decrease. For instance, you might give an algebra test to preschoolers. Well, they're not going to do well on that exam, and no matter how well you try to train those preschoolers, they're just not going to get it. Okay, it's going to be 0 or very low. No matter how much you try to intervene with these preschoolers, they're not going to do well on that algebra test. Or as a more application here, maybe there's a mental health study that's using a depression questionnaires with questions like, do you feel extremely hopeless every single day of your life? And well, the general population in this sample might say, well, no, not really. I don't really express that high level. And so there's not going to be an ability to detect milder levels of depression because our measure is kind of setting the bar too high, and so everybody's going to be at a low end of that scale. So how we word our measure matters as well. Finally, we might have a reverse design confound. You might remember from last time that a design confound is when something about our conditions is different across our independent variable levels besides our independent variable. So I used the example before of maybe we're trying to remember things from either taking notes by hand or typing them up. But if the video is more interesting or boring, it's going to change the outcome. Or if the quiz is harder or easier, it might change the outcome. Those are design confounds. A reverse design confound is when you're doing something similar, but it's causing there to be no effect. Like you're changing something about the conditions, but in a way that it reduces your ability to find an effect. It kind of obfuscates the relationship rather than accentuating the relationship. So we need to keep in mind that science just might not work sometimes. And it might be because there's no effect. It might be because just really your hypothesis was wrong. There's nothing out there. But you should always be looking at these other things about how you are assessing, how you are manipulating, how you're assessing your dependent variable, and whether or not there's any other kind of confound that could be affecting your outcome. Other other reasons why it might not work, then it might find a null effect. You have to remember this unsystematic variability. We talked about systematic variability as when different conditions are kind of experiencing different things. There's a systematic way that individuals are different. You're hoping that the systematic variability comes from your independent variable, but if it doesn't, if the systematic variable is coming from something else, it's the design confound. However, there's always going to be unsystematic variability. This is the random noise that are just people being different. And we are hoping through random assignment that the amount of noise in one condition is similar to the amount of noise in another condition. But sometimes that's not true. And we might have some kind of measurement error, which is noise that is caused by imperfect measures. We might have just random individual differences among the participants that's causing a null effect. And we might have random differences in the context of when we're studying, how we're studying. And all of these might lead to a more systematic variability. And these are all things that we should be looking for. And this is something that we're going to talk about when it comes to our discussion sections, when we're talking about them in lab, that we write up about. When we get a result, we should always be thinking about what were the threats to validity in the study and why did I get what I did? And especially if it's unexpected, you get a null effect when you're expecting to have a research effect. Why might that have happened? What are some sources of noise or systematic variability that may have played in? Was there a floor or ceiling effect? Was there issues in the manipulation or the measurement? And that's the kind of thing you're going to see discussed in a discussion section when people are trying to interpret. In fact, everything we've talked about in this course over the past few weeks about how to design experiments, how to make sure you are accounting for bias in your observations, how you're making sure that you're actually getting construct validity and measuring the inter-item reliability of your scales. All of that is the stuff that you're going to see in discussion sections when people are talking about why did they find what they found. You don't necessarily always have to talk about in terms in these like jargon that we are using in our course, but you do want to discuss those implications. That's what the discussion section is for. All right, so that was a lot. So here's a quick summary. Again, there are multiple threats to validity. It could be that people are different, people change, or that studying people changes people. And we had a lot of examples of how those might manifest and different things that we need to keep in mind, because you do need to keep those issues of validity constantly. That's basically what this course is about, is that just because we put an experiment together and we think that we're studying what we think we're studying doesn't mean we actually are. We spent a lot of time talking about the different forms of validity, and all of those should be in the back of your mind every time you are both putting together your own research as well as reading other people's research and interpreting other people's research. Just because people say that two variables are related and there's a headline in a research article that says, hey, X causes Y, doesn't mean it's true. We have to look at the way people were measuring things, the way people were manipulating things to see, does it make sense? Are there potential other explanations that might reduce the validity of this study? And I get to say, well, yeah, your study said this, but I don't think it's true because you didn't account for all these other interpretations. So you should be thinking about that for your own research and for everything that you consume. We are both producers and consumers of research, and we need to keep validity in mind. We should also always keep in mind that there are many reasons for null effects. It's not that you're a bad researcher or the person who did the project is a bad researcher. There's a lot of other things that we should keep in mind to consider the validity or the way that the experiment was run that may have led to incorrect solutions. And that's something we're going to talk about in lab, with the idea of finding something that maybe isn't true with our type 1 and type 2 effects. As an upcoming things to look forward to, next time we're going to talk about how to run experiments with multiple independent variables and interpreting the output of those. And you should also be working on lecture assignment 3. Right now that assignment is to read an article and answer some questions about that article, and you're going to do a little experiment yourself. Well, not an experiment. You're just going to do a little manipulation dependent variable yourself. So go ahead and check that out, and that's going to be due soon. All right, that's it. Have a good one. See you next time.